Hello students, let us see the structures of oxides of nitrogen. So how to draw the resonance structures of oxides of nitrogen. So there are different oxides of nitrogen. First one is N2O, that is nitrous oxide or dinitrogen oxide. So let us draw the structure N2O. So we can draw double bond. So this N satisfies octet, that means 2, 4, 6, 8. So now we can give electrons to this nitrogen, that means 2, 4, 6, 8. Here 2, 4, 6, 8. So this will be the first structure, and the second structure will be, so if you are shifting this electrons towards it and this bond pair towards it, we will get another structure, that is nitrogen, one pair of electron here, then it will be a triple bond, then nitrogen, single bond, oxygen, and 3 pairs of electrons. So this is the structure. Then NO, that is nitric oxide or nitrogen monoxide. So this is nitric oxide. So here it is nitric oxide NO. So since it is having actually it is having 11 valence electrons, 11 electrons. So nitrogen is having 5 electrons in the outer shell, oxygen is having 6 electrons in the outer shell, total 11 electrons. So we need to put a double bond here, then 2, 4, 6, 8 here, then 10 and 11. So this will be the first structure. Then second structure is nitrogen with 3 electrons and oxygen with 4 electrons. Nitrogen with 3 electrons and oxygen with 4 electrons. Now let us see N2O3, that is nitrogen trioxide or dinitrogen trioxide, N2O3. So N2O3. So here there is a double bond, here it's a single bond, here also there is a double bond. So this nitrogen 2, 4, 6, 8, here this oxygen 2, 4, 6, 8, here 2, 4, 6, 8. This nitrogen 2, 4, 6, 8. This oxygen 2, 4, 6, 8. So this is the first structure. Next one will be like this. Here the same procedure. So this nitrogen 2, 4, 6, 8. Here oxygen 2, 4, 6, 8. Here 2, 4, 6, 8. Here 2, 4, 6, 8. 2, 4, 6, 8. So these are the two structures of N2O3. Then NO2, nitrogen dioxide, NO2. So it will be, so nitrogen dioxide, one will be a double bond, and here we need to check the valence electrons here. So here nitrogen is having 5 electrons, oxygen is having 6 electrons, total 6 plus 6 plus 5. So that is 17 electrons to be distributed. So here 2, 4, 6, 8, 10, 12, 14, 16, 17. So actually this is an odd electron species. NO2 is an odd electron species. So the resonating structure will be, another structure is, here there is a single bond, here there is a double bond. Here 4 electrons, here. So here also we can see an odd electron. So NO2, actually nitrogen dioxide, this is an odd electron species. Now let us draw N2O4, dinitrogen tetroxide or nitrogen tetroxide. N2O4. So N2O4 will be like this. So one will be a double bond, other will be a single bond. Here also we need to check whether it satisfies octet. So this N 2, 4, 6, 8. Here 2, 4, 6, 8. Here 2, 4, 6, 8. This nitrogen 8. Here this oxygen 2, 4, 6, 8. Here 2, 4, 6, 8. So this is the first structure, and the next structure is double bond O. Here also double bond. Here it is single bond. Here it is single bond. So we can distribute the electrons here also. Here it will be two pairs of electrons. Here it will be 6 electrons. Here 4. Here 6. So this is the structure of nitrogen tetroxide. Then next one is N2O5, nitrogen pentoxide. N2O5. So N2O4 is like this. So N2O5, 5 oxygen atoms are there. So we need to arrange the oxygen in between 2 nitrogen atoms. So this will be the structure. Here also one will be a double bond, the other will be a single bond. So this will be the first structure, and here nitrogen 1, 2, 4, 6, 8. Here 2, 4, 6, 8. Here 2, 4, 6, 8. This nitrogen also already satisfies octet, and this oxygen 2, 4, 6, 8. Here 2, 4, 6, 8. 2, 4, 6, 8. So this nitrogen satisfies octet 2, 4, 6, 8. So this is the first structure. So next structure is here there is a double bond, here it is a single bond. So the same procedure can be used to distribute all the electrons in this case also. So it will be like this. So this will be the structure of nitrogen pentoxide. So in the case of NO2, we have seen it is an odd electron species. So actually this nitrogen dioxide form dimers. So we need to note that point. It form dimer. Since it is having an odd electron, it is an odd electron species. If it form a dimer like N2, it is NO2. If it is a dimer, it will be N2O4. So this is a stable structure. This is a stable structure with even number of electrons. So NO2 form a dimer because it form N2O4. It is a stable structure with even number of electrons. That is, one point is to be noted with nitrogen dioxide. Then N2O5. So N2O5, here there is a question. What is the covalency of nitrogen in N2O5? So what is the covalency of nitrogen in N2O5? So how many bonds are there with nitrogen in this structure, that is N2O5? So it is 1, 2, 3 and 4. So 4 bonds are there. So the covalency of nitrogen in nitrogen pentoxide is 4. So these are the 2 points to be noted while studying the oxides of nitrogen. So this is about structure of oxides of nitrogen.